Here we have worksheet 1 from Charles Law. We're going to do the first question together, focusing on how I like to attack these problems in really 3 main steps. First of all, I'll just say that Charles Law does assume constant pressure. Notice there's no pressure in the equation. That's how we know it's held constant. And also constant moles. And so with that, we can focus on volume and temperature, how one changes into something else. And so we read the equation, trying to decode it as best we can. Gas system has an initial volume of, there's liters, so that's my V1, 4.32, and my Celsius is temperature, and that's T1, equals 150 degrees Celsius. Now the couple things to note is that these happen at the same point in time. That's why it's V1 and T1 as opposed to a V1 or a T2. These happen at the same time, so they get the same subscript, so they are put together. Now is liters is fine unit for Charles Law, but Celsius is not. We have to convert it to Kelvin using this equation here, adding 273 gets 423 Kelvin. Gas laws are always going to be in Kelvin, so 0 Kelvin equals no energy, as opposed to 0 Celsius, coincidentally, I guess not coincidentally, but somewhat arbitrarily means freezing of water. That has its uses, 0 Celsius being freezing and 100 degrees being boiling. For Celsius, but that's not what we need. We need 0 to be 0, which means these gas particles are not moving, no collisions, and no pressure. That's what 0 has to be. So always convert to Kelvin. Now I'm going to read the rest of the question. When the temperature changes to 329, so I have a new temperature, 329 Kelvin, what is my new volume going to be? So that's my unknown, that's my X. So the first step I call take an inventory, and then I'm going to do the second step, which is the algebra. V1 over T1 equals V2 over T2. We need to isolate V2 as best we can. You can do the algebra in a variety of ways, cross multiplying. I tend not to cross multiply, but I know that's a popular choice. I'm going to multiply both sides by T2, so I can get T2 V1 over T1 equals V2. So that's doing the algebra the way I want to. You can do your algebra any way that you want to. Now the third step is to plug and chug. So I took inventory already, so T2 is 329 Kelvin. V1 is 4.32 liters. T1 is 423 Kelvin. It's already set up to be the correct units, matching units. I take care of that when I take inventory. I don't go back into try to decode the equation again. I already did it when I took inventory. Now you can plug these numbers into the calculator and you get the desired answer, 3.6 liters there. The liters comes from the initial unit here. The unit doesn't change from beginning to end in the context of the equation until you actually have to convert it. So this question asked for liters, so I didn't have to do anything. But if it asked for milliliters, I'd convert it, or ounces or gallons. I would do whatever I have to do to convert this to some other unit if I had to. X line, drag down the unit, and convert it to whatever unit is being asked for using dimensional analysis like we've done in the past. I hope that helps. Go ahead and try the next few out. Again, you can do the algebra any way that you want. Make sure your temperature is in Kelvin. Make sure your volume units match whatever they are, whether it's milliliters or liters or anything else.